Hello and welcome to, this is the first time you get to see me. By the end of next semester you will have seen this type of situation a lot. But I wanted to set up and go through this PowerPoint about brain-based learning because I really think this is an interesting topic. You'll find that you learn a lot as we go through this subject. So let me go ahead and start my video up. There we go. My PowerPoint up. And we'll start. Exploring the brain, research, theory, and classroom application. We're going to look at this kind of thing here. First of all, let's talk about, there's been research, and as we've seen in our 3090 classes now, how we learn has become more and more a subject of study from the very earliest people beginning to think about how students learn. It started back with folks even like Comenius, who said we need to consider the child. Froebel certainly wanted to consider how children learned. All of these guys talked about hands-on learning. But what we really need to know is the types of things we learn. We have things, of course, that are personal that we do, and we learn things that we're required to learn to have to do. One of the first things we do when we are things that we're required to learn is to gather information. Either things through direct instruction like we get in class sometimes, or things of examples that people show us. These modeled examples are not necessarily formally modeled things. Children get shown how to behave by the way other children behave. You don't plan that, but they certainly learn from watching that modeling. And as I just said, watching that model. We also learn, of course, by trial and error. This comes from authentic experiences. I used an example in class the other day about how students, when they're out to play and it's after raining and you've got a little stream running across down a ditch or something like that, and one of the things that we've all experienced is trying to dam up that stream, and you realize through trial and error what works and what doesn't work, what lasts and what begins to fall apart as you go through. That same type of trial and error is how we learn a great number of things in our life. And then, of course, there's practice, practice, practice. My piano teacher used to say to me, it's not always practice that makes perfect, it's only perfect practice that makes perfect. So that is still a way we learn. I like this thing called creative mistakes. Some people make creative mistakes and they learn from that part, but hopefully we can allow them to have safe errors. There's a product called Lexan that they make large plastic windows out of, and you've seen those plastic cubes that have a pin and things like that. Lexan was actually invented by a mistake in a lab, where a lab researcher had tried to stir up something else and it didn't work, and so he just left it all there together. He was disgusted, and when he came in the next day it had solidified, and he realized that what he had accidentally made was a product they later named Lexan. And of course, once we have done something or experimented with something, we have to evaluate how well it's meant to us, as well as what it means to others of things that we've learned. So you have to evaluate those things in terms of self and others. And then, of course, one of the last time, it's actually sort of in the top end of Bloom's taxonomy, in that we learn how to generalize, how to create new things or improve on things. Next. Look at this thing. Cognitively unimpaired, in other words, those people who don't have a particular learning disability or things like that, they have an innate learning system that we are pre-wired for learning in our brain. We don't come totally, which I don't think it's a blank slate, as one of our earlier researchers believed, or theorists believed, but we certainly are pre-wired for learning and have some things that come from our innate hereditary systems, as well as from the things that we then later learn. But if the ground is already plowed and set for us, all we have to do is assist and make things happen in the area that's already there. Albert Einstein used to say that he doesn't teach his students, he only provides the conditions under which they can learn, and that follows right along with brain-based learning. So let's look at the principles of things. There are 13 of them, maybe 14. I'm going to go through these in detail, but you might want to write these down or make a note of these, that learning is physiological, that practice grows new structure. In other words, putting things that you've learned to use grows literally new structures in the brain, and that brain structures grow specifically for those learning purposes. They literally have a specific purpose. Once you've determined in your body, your brain has determined what the purpose is, it literally structures that. It depends on where in the brain that it places it. We talked about scaffolding, helping new learning grow off of old learning. Look here at number 4, brain structures grow from individual experiences, and that new brain structures grow off old structures. So obviously we need to make that connection so that the children's brains can make that. Number 6, I think, is one of those obvious things, but the brains actually grow when the learning is actively happening. You start new brain structures growing by teaching, by creating learning experiences in your classroom. And the stronger those learning experiences are, the more brain you literally grow inside a child. I think that's something to really think about. This 7th point, emotions affect the growth and structure of the brain, as well as how well the brain works. Genetics, health, and injury. We were talking the other day about Maslow's hierarchy of needs. Those things apply to the brain. When we set these experiences for children, we have to make sure we satisfy those lower levels. And those things, if they're not, can affect the way the brain structure grows. Number 9, brain structures grow when the brain is challenged, which means that we then as teachers must challenge our students to learn things, try to create that sense of wonder, that sense of what if and what is this, so that we can literally help their brain to grow. And number 10, we learn the obvious thing that the brain is what's called a parallel processor, and we'll talk about that some later. The brain is a computer. We all know that, but it is such an amazing computer that it is so complex, we still don't know exactly how it works. 11, the brain searches for meaning. In other words, when the brain learns something, it strives to categorize that learning, to place it in some sort of, we literally try to pigeonhole it away so that we know why that thing is learned. The brain, number 12, the brain is innately social and collaborative, means that obviously brains like to interact. You like to have another brain to bounce ideas off of, so to speak. So that points up the social aspect of learning in the classroom. 13, the brain needs downtime or processing time. And we'll look into that a little bit. I think it's one of those obvious questions too, but we'll look at it in some detail. So, look at these different parts of the brain there. Each little part of the brain has a particular function and works in that process in there. This is these brains, both these brains in these two pictures here, I'll back up again. These two brains here are both looking, the eyes would be on the right side. But notice the occipital lobe, I'll put the cursor, if I've got a cursor, there's a cursor, right here, where the brain perceives what they see is actually in the back of the brain. So that's why the optic nerve literally goes from the eyes all the way through the brain, all the way to the back of the brain, where what we see is interpreted back in the back of our brain. Next, the center part of the brain, what's called the midbrain, is often referred to as our reptilian brain. This is the basic response, fight or flight, fear, safety, all those things usually are interpreted and handled from that central area. All the outer cortex is for memory and for other processing of other functions in the body. Let's see. Now we've got a brain that's now looking to the left. So we can see how this same side here, we have these different sections here. The auditory cortex, notice, is right on the side there. This purple area right in the center there is right on the side close to where the ear is. This area, Broca's area, has to do with speech. My own mother fell and hit her head and got a contusion where she had some bleeding inside of her brain, and she lost completely for a few days the ability to speak. And then as it came back, it's interesting how she would be able to speak. She could tell me things or how they functioned, but she couldn't tell me the name of it. She would say, yes, on the, that thing you pick it up and you talk into it, and I would say telephone. She said, yes, telephone. She couldn't come up with the word. Well, she's back to her normal self now, but it took about 6 months for her to get past that as that part of the brain healed. Let's go on. This is literally a brain cell. The axon is this connection here that follows along this myelin sheath here. And the axon, or the dendrite, are these little branches off here. This whole cell is a brain cell. And these strings linked of these shells here are where electrical impulses travel along, and the branches on the other end are intertwined with another brain cell, so that things are linked just like telephone lines across down the street between different parts of the brain. You often hear of people having MS, multiple sclerosis, which is a disease of this string, these yellow cells in that picture, that the connective juice, so to speak, that helps the electricity conduct along that line dries up and creates blank spots in there so that the signals get through intermittently. And people who have MS very often have drawn muscles, or they move very herky-jerky in that process, and it comes from a disease in that place right there in a brain cell. So, learning is physiological. As I mentioned in class the other day, teachers deal with about 100 pounds of brain tissue floating several feet off the floor. That's actually what we are teaching, is that small little lump of tissue there. We have to remember that new brain structures grow during learning, and the teachers are either growing those dendrites, those stringed pieces together, or letting them wither and die. Now, what kind of classroom do we want? Obviously, is the kind where we're growing new things. How are we going to grow the brain? Look at this. At birth, there's 100 billion brain cells, 50 trillion connections already set up in our brain. We are wired to go. But by the teenage years, look at the bottom there. Half of those connections are gone. We lose those through attrition, through injury, through poor nutrition, from lack of stimulus. And it's amazing that it's a wonder that we have many brain cells left at all by the time we're adults. But we are born with almost all of the connections we need to ever need. And actually, as our brain grows larger, the connections swell with it, but we are still losing those connections in the process. Almost half of those are gone. So, use it or lose it, it certainly applies when it comes to the brain. We see that connections are used often, repeatedly. Those are the ones where we stimulate learning along a particular area. Those brain cell connections tend to grow thicker and even make additional connections to that process. Those that are unused tend to wither and die, and you lose those connections in there. Thus, we certainly have to use it. Early experiences, in other words, in the birth to age 3 area, both positive and negative, help to shape how the brain grows. Both positive and negative experience help to shape that. So we want to be able to create interaction where we have a lot of positive experiences, where we have people and objects and experiences that stimulate us and that will stimulate brain growth. Oops, I like this. There's a child's brain right there. An adult brain has the same limbs, the same amount of connections. However, it's filled out with all the additional knowledge that we've provided for them in the process. Number 2, brain structures grow with practice, which we mentioned earlier. Learning how to apply things, how to transfer what we learned from this thing to that thing, how to generalize, all of those things. They're the top parts of Bloom's hierarchy too, apply to the brain learning. But they only occur after practice. I like this. Brain structures grow by students making and correcting mistakes. So sometimes there are very often times, when you want students to go ahead and make the mistake. Let them go ahead and answer the question wrong, and then help them to see where they got wrong. They actually retain the learning better than if you just said, no, that's wrong, what's the right answer, and called on a different person. So there are times where we want to give students the opportunity to be able to correct their own mistakes. Finally, brain structures growing with practice. Practice, practice, practice. And this is what I was just talking about in the previous thing, where teachers say, that was a good mistake. So what did you learn? Well, I learned I have to put a drop of fluid on this slide before I go to float my microscope slide piece on the top of that so that it'll fit underneath it, because if I just drop it on it, the slide piece will tilt off and perhaps slide off to the side of the slide, or some process that they've done in that process. You want to allow them to make a mistake and then to learn from it. Once again, this cements this business about authentic practice, and feedback with it is time well spent. Number 3, brain structures grow precisely and exclusively. Shows that even though the brain structures grow with one specific purpose, if you reuse that learning in a different way, it'll grow an additional connection, so that a well-used area will look like a very thick spider web with multiple connections to this one little bit of learning. It's the construction, they create elaborate neural networks between these neurons that help students get new understanding. Brain structures growing from individual experiences that the environment that we use to create for our children helps them learn, and it has a great deal with the functioning of that brain. And let's say the brain that takes shape is the result of the interaction between the individual's genetic makeup and everything else they experience. So they're born with a certain genetic makeup, and then we provide and fill it out as much as we can with the individual experiences. Excuse me. Active processing allows students to review how and what they're learning. So while they're learning this process, it allows them to see and make an evaluation as to how they learned and how well they learned it. And this has to do with Gardner's multiple intelligences, that you should provide multiple ways for students to learn. The visual way, tactile way, emotional or auditory preferences. All of those things provide ways. So that's another reason why you should differentiate your instruction with your students. Think of a different way. If it's a way that they're reading it, can you have them draw what they learned? Can you have them listen to something that applies to that they learned? So that you have different ways to be able to make those connections with the children. Brain structures grow off old brain structures. I think this is almost, once again, a slam dunk. We understand that we have to connect new things that we learn to previous things that we learn, so that connection cements itself much better. Always start new learning by stimulating each student's neural network that are related to a new school. In other words, you want to stimulate them saying that we've learned this, and so now, because of that, we're going to take that and learn this. This picture here is a pretty good example. This is an electron microscope picture of an actual brain cell. And you can see where an enriched area, an area that's used a lot, has only a single line of connection to an area that's not used very much. With a thicker cortex, the denser cortex in our brain is created by that. Whereas the more spines a particular area has to a dendrite, the more connections that we make with our learning. Brain structures grow only when learning is active, through trial and error exploration. Now, when they see how whatever it is they're learning applies into real life, it helps to make a better connection with that process. So the more active we are, the more nerve cell growth and the more schema construction, those strings of neurons going together. Emotions affect the brain. That they've discovered that emotions and what we learn and know can't be separated. I like this phrase, and you need to make a note of this, that when we feel threatened, we do something that's called downshifting. Downshifted people want to withdraw, close off. They feel helpless. I don't know what to, and you've been to this way when you get toward the end of the semester, you've got so many projects that are due, so many things that are over, and you're feeling overwhelmed, and you want to, it makes it even actually harder for you to learn by doing this withdrawal process. You don't look for possibilities. You don't want to explore things. You don't want to take a risk. You just want to get it done and get out of that stress situation. So a hopeful student and a discouraged student learn differently. Now, a student that is hopeful, that they feel positive, that is one of the reasons why we should help our students see themselves in a positive light, so that we can help them find a way to, a better way for them to learn. Anxiety. There are really there's good stress or good anxiety and bad anxiety. There's a facilitating anxiety. That's one of those things of, oh, I've got that presentation to do tomorrow. I better put the finishing touches on it. That's a good kind, where you worry a little bit, and it tends to stimulate you into a little bit more active. However, if you get to that point, like, there's no way in 24 hours I can be able to write this entire research paper, I know I'm going to fail it, or there's no way that I've gotten so far behind that there's no way that I can pass this class. That kind of anxiety is a debilitating, where it makes it even more difficult for you to learn. So you don't want to create this debilitating anxiety in your classroom as a teacher. Genetics, health, and injury affect the growth of the brain. We have to teach our children stress management. We need to teach our children nutrition. We need to provide them with exercise and drug education. All these types of things, anything to help improve their health, because the healthier they are, the better they can learn. While we may have the same set of systems in our students, the research says that they're integrated differently in each and every brain, which means those systems apply and work in each brain differently, which means the better we know our students, the better we can differentiate our learning for them. So when we're instructing our students, we cannot have a student come into 4th grade and say, well, okay, let's start at 4th grade reading level. You have to start at the level the students are, not the level that you want them to be. So that's the importance of knowing where students are in any of the different subjects that you're going, so you don't go over their head, because you create the stress, and that then again gets into that debilitating kind of anxiety. Instruction that's boring, redundant, below where they are ready, where they already know this, then you get apathy. Your students say, yeah, I know this, I don't want to do it, or it's too slow, I got this when you said that the first time. You need to find out where your students' readiness levels are, and make sure you apply and approach it at that point. The brain's a parallel processor. I like this point here. The brain can, when we are thinking, even as you're watching this PowerPoint and watching this video, you're thinking about other things. And at the same time, the brain is automatically taking care of your heartbeat, your breathing, your temperature regulation, your digestion, all of those different types of things are all being put together and managed by the brain at the same time. When computers first came out, they were one-way processors. You put some information in, it would take it in, and then it would put information out. It was a one-way street, basically. Then they got to where a two-way street, where it would have a lane of information coming in and a lane of processed information coming out. So that would be what you used to call by then it was what we called an 8-bit. It was 4 bits of information going in, 4 bits of information coming out. It was basically like a 4-lane highway going in and a 4-lane highway coming out. You think a 4-lane highway in and out is pretty good, but 8-bit processors are not where we are today. In current computers right now, it is, it's past 512 lanes each way. Imagine how much traffic the computer can think about. 512 pieces of information coming in at a time and 512 pieces of information coming out at the same time. That is a huge thing. That is parallel, where they're processing side by side, in and out at the same time. Well, the brain is currently, at the last thought, the brain is about 17 times faster than the very fastest computer we've ever made. It still automatically handles all of these things automatically, and plays what if, and interprets things, and has feelings, and all of these other things, aside from the autonomic things that are going on. It's an amazing thing that we have in our brains, and brain researchers are still not really sure how it manages to keep all of that information. Because if you think about even an animal as small as a fly or a flea, still has enough brain processing power to be able to help it through its entire life. How on earth a fly can react to you swatting at it so that it can get out of the way quicker than you can be able to catch it with its tiny brain processing area shows us just how little area it takes to make an amazing amount of processing power. So imagine, apply that to what's available. It's often said that we use probably less than 10% of our actual brain capacity through our entire life. imagine what it would be if we could unlock that other 90%. It's amazing. So, all of those things operating at the same time. The brain can do several things at once. Which then reminds us that we should involve all of the senses other than just sitting and listening to you talk in processing and learning new information. As a teacher then, this bottom phrase, look at this. The teacher should orchestrate dynamic learning environments. Okay, the word dynamic here means changeable, changing as the need is required of a learning environment. In my classroom, when I was teaching music, my classroom would be set up one way for kindergarten class and an entirely different way for a 5th grade class, a dynamic environment there. But orchestrating that is, the word orchestrate means you determine at what parts of the day you do these things, at what parts of the day you do more complex things, at what parts of the day or what parts of the lesson you use introspective and interactive things, so that all of those things should change as the environment continues, as your lesson continues, so that you can stimulate more learning. The brain searches for meaning. Now, whenever I come to this part in the lecture, I think of that dog who hears a sound and he cocks his head to one side because he's always trying to process, what is that? And I think students often try to do that with us too. So we need to make sure we provide the meaning for them as we are teaching them things, which is why we should teach them the academic vocabulary that we're using, helping them understand the words and the terms that we're using, and providing them with logical basis behind some things, because things that are not connected with other things or things that are just out of the blue, they don't get. That's what I just said. Teachers need to help students find the meaning of new information and use stories, use complex things, and use metaphors. That provides a stimulation for that part of the brain so they can figure things out. That's why fairy tales and things like that have, and the meaning of the story is, help them to see things by teaching by parable and allegory, things like that. The brain searches for meaning. We try to find the patterns in things. In our early teaching, even with beads and manipulatives, they start stringing together things. 2 yellow and a blue, 2 yellow and a blue, 1 red. 2 yellow and a blue, 2 yellow and a blue, 1 red. To start patterns and start looking at more complex patterns and things. To find patterns in life. Help them to see repetition of things in nature and in the world around them, so they can see those patterns. So the goal is to move from memorizing to meaningful understanding. The brain being social means that we need to provide social interaction ways for students to be able to discuss things out loud, to bounce ideas off, to work in collaborative learning. And I've tried to foster that in this class, about learning how to work and bounce ideas off one another as you're trying to solve some problems in this class and in the following class, where we'll be able to do some things and be able to do collaborative work. And because our brain is a social brain, we need to foster social relationships, authentic relationships in the classroom, not only just student to student, but teacher to student, so they can help make better connections. The brain needs downtime. Have you ever waked up in the morning after a problem that you had that you couldn't figure out, and suddenly you wake up first thing in the morning and bang, you've got the answer to it? It's happened to me several times in my life when I had major things that I just couldn't come up with the answer. And the next morning I'm standing in the shower and bang, I know exactly what it was I'm going to do. I was trying to create a new show for a theme park in San Antonio, and I was scratching my head, what is this new show going to be about? And I finally put it away, went to bed that night, woke up the next morning, and I'm literally standing in the shower, and I had to call my wife. I said, quick, sit down and write this down, because the answer came to me in a flash. I knew exactly what the show was going to be about from top to bottom. And my brain had not stopped working on it, even though I thought I consciously had stopped working on it. My brain kept working on it overnight and solved the problem for me. We've all experienced those kinds of things. However, when we learn new things, they put those neural nets where they measure our brain activity on our heads, and they are measuring electrical activity in our brains. And when we first learn things, a lot of times it's right here in the frontal lobe. But literally 2 or 3 days later, if you ask them about those things that they learned, this part of the area does not light up. Instead, other areas of the brain, that learning has literally been reshelved in other parts of the brain. So we need to have time for students to process this idea of allowing them to store this and then re-stimulate it so that we strengthen those connections in different parts of the brain. That's why if you teach something and then immediately test over it, you're testing it right here, not where it's been stored later. So you make sure that if you do want to do this immediate testing, that's fine, but that's just short-time recall. The long-term recall is from other areas, and you have to give the brain time to put it away. The brain never sleeps, even though our bodies do. So, well, there's downtime allows the new synapses that are formed to strengthen based on how they need. And I've already talked about short-term memory move to other places. Non-challenging time. Now, for me, downtime is sitting in front of my computer. It can be doing a Sudoku puzzle, even though that's, to me, some people might be challenging. To me, it's just sitting and filling in numbers and things. Some people like to do crossword puzzles. Some people just like to sit and stare at the television. But we all need time to be able to just cool off and let the brain take care of its business. It's that also is connected with the reason why we should make sure that children get enough rest and sleep, and then we need to teach them about that so that their brains can grow and process what they've just learned. Downtime allows the learning to move into longer-term storage, I just talked about, and that's what I just talked at the beginning of there. So we have to make sure that we have downtime or processing time. I worry about the fact that we're taking rest periods out of kindergarten classes where children are not allowed to have some break time. For some children, it is the only quiet time they have to rest in their lives because it's too noisy at home, because of people who are up and down and awake and playing music and playing the television at all hours in their lives. And sometimes that hour of rest that they get in kindergarten may be the only time they can really have quiet downtime for their brain to be able to process the things. And I worry about taking rest period out of kindergarten, for that matter, first grade. But that's something I can't really control much. If the school absolutely outlaws it, you have to be able to find some other way to give them those quiet downtimes. Maybe they don't have nap time, but you can still have quiet listening, reading times. The storybook time, the time for them to be able to just sit and listen to music, allows them to rest so that the brain can process those things that they're not even aware is going on. If we don't, they tune us out. You know that. So, to teach a student, you have to teach the student's brain. Brain-based learning is not relying on handouts as the major means of your instruction. If you're going to be that kind of teacher, I'm afraid you may not last long in this profession. It is not teaching in a passive manner. Teaching these days is not a matter of the teacher sitting at the desk with the apple and the box of pencils and the papers while they're grading papers while the students are all doing problems 1 through 25 on page 56. Those days are gone. If the principal comes into your classroom to observe you and you're sitting at your desk, likely you and the principal are going to have a conversation about how you need to be moving around amongst those children, and the children need to be moving around amongst themselves as they move from place to place while learning is coming out. I know that there are times in the classroom where you need to stand and be still and they need to sit and listen to you teach, but those times need to be rare and far in between. So make sure that happens. Testing in a format that doesn't match the learning. If you're having them to learn in a particular way, then you should test in a way. Now, the researchers and the research and the decisions about this business, about saying we need to test students in the way they learned, and then when it comes to standardized testings, what do? Paper and pencil and bubble in. Now, we're getting away a little bit from that in that we're having more essay writing, more writing where the students can actually create and write down the things that they do. But some of the learning that we have our students do is not created in that manner. And I think we need to find and understand, or help people to understand better, that if you're going to teach it in that way, you need to test it in that same way. I think probably part of the answer to that is that you don't just teach by one particular method. You use a variety of those methods to cement the learning, and then you test by the one method, which will hopefully capture in an equal manner the amount of learning that students have. Okay, and teaching before the processing is taking place. I talked about that earlier, about if you teach something. I've known teachers, even professors, who have taught something in a class, the first half of the class, and then given a midterm exam immediately after that. It doesn't, to me, it doesn't make sense, because you've just learned something and you've not had time to actually process that and put that into the parts of your brain where they need to be. However, that still continues to live on. Brain-based learning is not grading without any kind of feedback. You need to be able to get feedback to your students so that they can understand how well they're doing. Criticizing mistakes in a negative manner is not a good way for you to help a student learn. It is not ignoring individual differences. It is not forgetting to make sure that basic knowledge is established. You have to know what the students' basic areas in each part that they need to learn is created. But use that as your springboard then to learn new things. And then finally, teaching new concepts without connecting to prior knowledge. We've said that several times. If you're going to teach them something new, help them make a connection with something they already know. Now, I placed this. This is a document that's also loaded in live text in our page that has some principles of brain-based learning. I think they're important to at least just read through and see some of those. So take a moment. You can even pause this video and read through these, or go and download this document. It came from a textbook on early childhood learning and the brain that applies to all of us. I look at number 6 is the one that particularly interests me. Our memory is very poor in rote, semantic situations. It's best in contextual, episodic, in other words, repeated, event-oriented situations. So that we understand that if we're going to teach, all of our teaching is going to be by rote memorization, our brain is very poor at putting that into meaning and attaching a meaning to that. That's the end of our video. I hope that you have a chance to have had a chance to read the articles and to write up your document about your 3 articles that you read, and hopefully we'll be able to discuss them in another week after we come back to class. So good luck, and thank you for watching the video. See you next class.